So are we good to go, Shashwat? So, welcome to the first session of Developer Weekend, a series of talks hosted by Equinox IIIT Lucknow, alongside with the Pan India Hackathon HackoFiesta 2.0. HackoFiesta is a collaboration of programmers, designers, and inventors to code, design, and build innovative solutions that tackle real-world problems. And it is going to take place from the 16th to 18th of April 2020. The session of Developer Weekend is being delivered by Logan Kilpatrick, community manager at Julia. He is a full-time software engineer, the community manager for the language, a teaching fellow for Harvard University, and a contractor at NASA for the Viber Lunar mission. It's a pleasure to have you here, Logan, and now over to you.
Thank you. I appreciate it. I was getting stoked just hearing sort of the introduction to spending the next few days hacking. So I'm excited for all the other students that are sort of going to get that opportunity to hopefully build something that's interesting and impactful over the next few days. And I'm also really excited to share with folks about the Julia programming language, sort of what it is, because I'm sure there's a lot of folks who have never heard of Julia before. And then we'll also spend a little bit of time talking about perhaps why, as a student, it might make sense to learn Julia from a career perspective and from a technical perspective as well. So I've got some slides to share. So if there's nothing else, then I'll share those slides. We'll hop in.
Your screen is visible.
Wonderful. Sweet. So if we sort of take a step back, and like I said before, my guess is there's some folks here who aren't familiar with Julia. And if you're not familiar with Julia, I would say the sort of best comparison that people are normally familiar with is a programming language like Python. So Julia is very similar to Python in the sense that the syntax is high level. You sort of have this notion of a language that's productive for developers. If you've ever used Python before, I think one of the things that you can attest to in comparison to like C++ or C is that it's super easy to write Python code. It might even be fun sometimes. So that's one of the really nice parts about Python. And when the folks who created Julia sort of sat down in the early 2010 timeframe and were thinking about what kind of language do we want to create? What are the problems inside of the programming language community that we want to solve? One of these problems was that, we have a great language like Python. And again, I think a lot of people will try to, make it seem like there's this competition between Julia and Python. I really think that it's they're both going to do well in the future. So one of the nice parts about Python is how easy it is to use. So that was sort of a core paradigm that the folks who were creating Julia wanted to take away from Python. So we now have the notion that Julia is sort of easy to use and expressive. And then the other sort of pieces that folks who were creating Julia wanted was this ability for the language to still be as fast as a language like C or C++. Because again, you sort of, that's one of the big challenges with Python is when you write your Python code, perhaps you can, make it work in sort of a prototype version for just running locally on your computer. But when you actually want to go and build something that's doing a computationally intensive task, and then you want to deploy that code out into the real world environment, the chances are you're going to have to write it in Python and then translate it to C or C++. And this is sort of the quote unquote two language problem in that, there's not just a single language that you can do your prototyping and your deployment in. And that's sort of the reason that Julia was created. So you can sort of see the high level facts here. The language is fast, it's dynamic, it's composable, and of course it's open source, which is really awesome. And also, I'll make a note. If there's questions, I can't see the questions on my screen right now, but if there are questions and there's things that folks are confused about or just want to know as we go through this presentation, I would be super happy to answer those. And that way, I'm not just talking at you for the next 35 minutes, 30 minutes. So if we look at some of the sort of core paradigms of the community and the Julia language itself, you have this notion that we were talking a few moments ago about computationally intensive tasks, and some of the most computationally intensive tasks are the ones that you see showing up on this first bullet point. So numerical computing, data science, machine learning, artificial intelligence, scientific computing, a lot of again, scientific computing incorporates like computing in specific scientific domains like biology, chemistry, things like that. So you have all of these different computationally intensive areas of computing, and these are sort of the areas where you see Julia flourishing. For machine learning, there's a ton of really interesting work happening using Julia. So it's if that's sort of a domain that you're interested in, machine learning, I would suggest taking a look at some of the areas where Julia is being used for that. At a high level, the language is growing from a use perspective at a really fast rate. So we have over 25 million downloads of Julia. That's growing exponentially compared to the last few years. Looking at 10,000 daily downloads, 5,000 packages have been registered in the ecosystem, which is a huge achievement for us. So there's a lot of really, there's a lot of state-of-the-art packages that are coming out, and folks are using Julia to sort of solve these problems, and also, again, solve them in a way that makes that package sort of the leader in the industry as far as solving some of these problems goes. And I think a great example of this is the scientific machine learning, the SciML ecosystem has a bunch of differential equations packages, which are not just what I would consider to be the state-of-the-art packages, but what many folks consider to be the state-of-the-art packages because of sort of how they're using Julia to solve these problems. And of course, Julia is being taught at a bunch of universities, being used by a bunch of companies, and we'll sort of look at that in a little bit more detail. So we were just chatting before this, before we went live, about sort of my Julia experience, but I actually started using Julia back in 2017, 2018 when I was interning at NASA, and the team that I was using Julia on, again, had a really computationally intensive task that we were a computationally intensive problem that we were trying to solve. So we, the folks who originally sort of started to build the project and think about the problem were looking for a solution, and it just happened that Julia had come out at the time, and they decided, hey, this might be an opportunity where we can use this new language to solve this really difficult problem that we're trying to solve. So it was a really great experience for me. I got to learn Julia, and of course, that led me to be here chatting with you all today about Julia, which is a full circle experience for sure. So if we take a look at some of the really interesting use cases for Julia, one of these really interesting use cases is the Klima project. And the Klima project is basically this collaboration between a bunch of different organizations that you see down at the bottom. And what these folks are trying to do is build climate models that are sort of at the scale of the entire planet. And again, if you sort of think about, one of the core challenges of climate change is that we don't have a good understanding of what the actual impact of all of these different things that are happening in the environment are on each other, and sort of what is interconnected, what is not interconnected. If we, if the sea level rises by 3 inches, what is the impact on all these other things around the world, all these other dynamic Earth systems? And you can sort of just start to think right now, like, just about how many questions this sort of idea brings up for you. And there's also a ton of like technical issues with trying to simulate what these impacts on these different areas would be, again, just because of the size and complexity of the problem. So the folks at Caltech and MIT and JPL and all these other organizations came together and decided, hey, let's try to actually solve this problem using what they're calling a climate machine and all this other, sort of a scalable platform and open hub, as you see on the right-hand side. But sort of the core piece of this is that they're using Julia to do all the computational processing. And so far, to my understanding, at least, they've had some success in what they're trying to do in their ability to model sort of more complex and larger scale systems, which is super interesting to see. Another really cool, again, hopefully just sparking some interest if you've never heard of Julia and sort of aren't aware of some of the use cases. Another really interesting use case, and we were actually, again, chatting about this before we went live a few minutes ago, but this PUMAS project, which is personalized medicine through a partnership with UMB. This PUMAS project it's pumas.ai is the website if you want to check it out. But they're basically using all of the scientific machine learning functionality that we were chatting about a moment ago to actually do a bunch of different like health related and pharmacology related applications. So one of them is personalized medicine. This is always just such an interesting thing to think about, and I love talking about it. But just the idea that we all sort of, I've given this example in a bunch of talks before, but the notion that we all go into a doctor's office, everyone who's listening to this talk, we all go into the doctor's office, we all sort of have the same symptoms, and theoretically we would all be given the same diagnosis for whatever the problem is. And whatever the problem is, they write us a prescription for some antibiotics, for example. To my understanding, we're all going to get the same dosage of these antibiotics, which if you, again, sort of start to think about it, we're all completely different. We're like, our bodies are completely different. We're all different heights. We all eat different things. We live in different places. So it's really interesting in that you start to think about, well, just based on logic, you would assume that sort of this, antibiotic regimen is perhaps more effective for some people than it would be for other people, or perhaps it's not effective enough for some folks and it's sort of overly aggressive for others. So they're at least one of the projects that the PUMAS folks are working on is sort of helping to try to solve this problem and build personalized medicine regimens for folks when they go into the doctor's office. And another really cool sort of application of a lot of the work that the PUMAS AI folks are doing is they're actually sort of helping, they help provide a lot of the infrastructure for the folks at Pfizer and Moderna to actually create the COVID-19 vaccine, which is super cool. And again, a great accomplishment for this team. The fact that they were able to provide such a timely sort of service to the world and helping get this the vaccine out the door. So that was really awesome and a great win for that team. And there's a ton of other use cases. Again, if your interest is perhaps perked a little bit and you want to know more about some of the cool places that Julia is being used, I would check out the juliacomputing.com /case studies. There, you can just go to the Julia Computing website. They have a bunch of really good case studies, and it'll sort of go into what the problem was, how the sort of computational improvement that came about using Julia. So lots of really cool stories to read about and use cases to learn about there. So another really awesome thing is that, so hopefully perhaps, at least for some folks, the interest has sort of been perked and you want to learn more about Julia and sort of perhaps get your hands dirty. One of the really cool things is that the folks at MIT who teach the Introduction to Computational Thinking class there, one, they're using Julia for that class, which is awesome. And two, they've made the class entirely online and accessible to anybody in the world. So if you want to learn, sort of take the Introduction to Computational Thinking class, learn Julia, learn a bunch of computational thinking ideas, you can go to computationalthinking.mit.edu or just type in Introduction to Computational Thinking Julia on Google and it'll show up. But again, this is a super cool opportunity for you to sort of participate in the class. That, you know, they do all the discussions on Discord, which is open to anybody. So it's a great opportunity to get involved and to learn. And so far, you know, I think this class has been a huge success, and lots of students have been involved in learning Julia. So I would highly suggest it if you don't know the language yet, but you sort of wanna get a strong foundation. So I'm gonna pause for a second before we hop into the contribution pathways to see if there's any questions that have come up that I can answer.
Sure. So there's a question that on which language is Julia based?
Yeah, this is such an interesting question. So Julia does have C bindings in certain places. But if you actually look at the core language itself, and this is such a unique piece of Julia, most of Julia is written in Julia itself, which is really cool. So if you go look at like the core language repository where all the functions and stuff like that are defined, you see that they're written in Julia. So if you learn the language, you can contribute to the language. And the same thing goes for like a lot of the machine learning packages and things like that. So if you know, like, I think it's TensorFlow or PyTorch, one of the two obviously is a Python package, but a lot of the code is actually written in C or C++. And if you look at Julia's machine learning packages, they're all written entirely in Julia. So if you learn the language, you can actually understand at a deeper level the infrastructure that you're using to do all the tasks that you've written. So very interesting in that regard.
So another question was, what is like, how is Julia so faster than the languages? The languages it has competition. So like Julia is pretty fast when we compare it to them. So like, how does Julia make that possible?
Yeah, this is another really great question. So this is sort of a twofold. There's two core pieces that have enabled Julia to be as fast as it is. So one of those is an intentional design. So when the folks built Python, sort of, speed wasn't something that they were building for. Speed is an afterthought in the context of Python. You have things like Cython, which sort of help you speed up your code after the fact. But when the folks were designing Julia, the creators, they specifically sat down and said, let's make this thing fast. So they did a lot of things from a design perspective that enabled that. One of those things is JIT compilation. So Julia is just in time compiled, or folks in the Julia community say it's just ahead of time compiled. But this allows you to have your code be much faster because of this JIT compilation.
So yeah, these are the questions till now.
Great. Those are great questions.
Another question is there. Is Julia compiled or interpreted?
So it is compiled, just in time compiled. So you sort of don't have to do anything. When I think of a compiled language, I think of like what I have to do when I run C++ or C or something like that. But it really functions more like Java and Python, in that you just run your code and it does the JIT compilation for you, and you don't really have to see that happen.
So I guess we're good to go now.
Cool beans. So let's talk about some, for students, what some of these contribution pathways are. And I put 3 down here, but there's perhaps more than these 3, and these are perhaps sort of all encompassing in the way that I've written them. But you have like basically 3 different options. So you have the sort of technical contribution pathway, in that you are actually contributing code to a project. You sort of, again, have this sort of technical contribution in that you're contributing documentation to a project. And then you have this whole other bucket of non-technical contribution. So in my role, as the community manager for the Julia language, most of my contributions, actually all of my contributions at the present moment, fall under the two categories on the right-hand side. So non-technical and then documentation are the two areas where I spend the majority of my time making contributions. And, there's perhaps a bunch of reasons we can go into as to why this is. We'll sort of ignore that for now. But the basic idea that I want to get across throughout the next 6 or 7 slides is that, there's this idea in computer science or in open source and computing and all these things that sort of, you have to go and like contribute code if you want to do something that's meaningful. And I think hopefully we can go through the next few slides and dispel some of that. I think for me, a documentation contribution can be one of the most important things that somebody can do. If you have some gap in your documentation, and you go in and you're the person who fixes that gap, that can be such an impactful contribution. Way more impact than contributing a piece of code in a lot of cases. So I would again hopefully we can sort of dispel the idea that you have to be a sort of a technical code contributor in order to do something meaningful. I think contributing code is great and it's awesome. And if that's what you want to do and that's sort of you found a place where you can do it, that's perfect. But there's also a ton of other ways that you can sort of get started and contribute to Julia and the sort of ecosystem. And again, before we go into the next slides, my other disclaimer is that I don't think that these ideas that we're talking about here only apply to the Julia community. So perhaps even if you sort of go through this and you're not convinced that Julia is a worthwhile tool and a language you want to learn, I would say the ideas here should still apply to whatever other computing sort of community that you're a part of. So if we take a look at like what a good documentation contribution would look like and sort of how that's an avenue for contribution, if we look at this this quote from Steve McConnell, who I don't even know who that is, I just found this quote online and it seemed like it would be interesting for this presentation. But Steve's saying good code is its own best documentation. As you're about to add a comment, ask yourself, how can I improve the code so that this comment isn't needed? So I at a really high level, I understand what Steve is saying here, and I can sort of agree in some sense that you want your code to be readable by itself. But I do think the idea that you shouldn't write comments and documentation for your code, and you should instead focus on making the code readable and not put comments in is perhaps not true. Again, I think I might be taking Steve's example to the extreme, but I do think that you need to write documentation and you need to write comments and stuff in your code. This is perhaps a better quote that I really like, and if I could get this on my wall, minus the picture of Damien's face, not that he doesn't have a great face, I'm just not sure I'd want his face on my wall. I think I would get this. I would get this put up on my wall somewhere. And the quote is, documentation is a love letter that you write to your future self. And I totally agree with this. If you've ever done sort of a technical project before and you've written documentation and then you've gone back to it, whenever I go back to my old projects and I look at my documentation, I'm always horrified. I'm like, how did I not write more documentation? Why was I writing it this way? This is such a bad way to write it, et cetera, et cetera. The same thing when you look at your old code. But I really do think that this sort of avenue and the reality of documentation is such a great way to get your hands dirty. And again, people who are new to a language or a package or something like that have such a unique opportunity, and they're in such a unique position to make good documentation contributions. And the reason for this is that you're sort of a fresh pair of eyes when it comes to looking at the specific project. Like, for me, for example, when I go and look at the Julia documentation, I've looked at it so many times now and I haven't looked at it that much, but I'm sort of like numb to the things that might not be written really well. And I think a fresh pair of eyes, like I sometimes have my little brother look at the documentation. I say, hey, what do you think of this? And he's like, well, that doesn't really make sense to me. And that's that's usually my indication that, hey, there's perhaps a better way that we could be writing this, because, you know, somebody who's looking at it for the first time is having a hard time understanding this. So again, I think if you're sort of a new contributor, a new user of a language or a package or something like that, look at the documentation, see what doesn't make sense to you, and then figure out a way that you can help make that process better for the next person who comes and reads the documentation. I think, again, this is the sort of the best and easiest way that you can sort of get some quality contributions to a language or a specific open source package. So the Julia documentation, this is just sort of what it would look like at a really high level. But if you were looking through the Julia documentation on any of the pages, you could just press the edit on GitHub button, and then you could go and either open an issue or actually make some specific contribution and try to change some wording or add some additional context, whatever it might be. So there's the ability to do this built right into the Julia documentation, which is really nice. Another technical documentation contribution actually could be outside of the traditional domain of the documentation for the package itself. So I think that's one route, but then the other route is to actually write about your experience using some package or using some language or something like that. So this, as an example, and I don't know Emmett, but Emmett is the author of this article titled "An Intro to Software Engineering in the Julia Programming Language." So I think this is a great technical contribution to the Julia community, in that Emmett wrote this article about how to do software engineering in Julia. And I think, again, if you think about like the normal context of a contribution, you know, people might not classify this as a Julia open source contribution. I really think that it is, because again, the next person who comes along who wants to learn about software engineering in Julia now has this article that Emmett has written, and that can sort of serve as a guidepost. The other piece of this is that from a learning perspective, you know, writing about and talking about what you're learning is such an impactful thing to do. When I was being introduced, the quote was that I'm a teaching fellow at Harvard, and it's true. I teach a class about web development using Python and JavaScript, and that class, just by teaching this class and helping students learn these ideas, my understanding of web development in Python and JavaScript has probably increased twofold. And again, I'm not actually doing any of the projects or writing that much code, but I'm just talking to folks about it and helping them with their code. And again, I think that's such a, you know, you don't really know something really well until you've tried to go and teach it to somebody, until you've tried to go and convey that idea to somebody else, and then hopefully have them ask you questions and say, you know, hey, this doesn't really make sense to me. Can you elaborate in this area? That's where the real learning takes place. So writing articles, technical articles, is such a great way to do this. So before we hop into the specific technical areas where you can contribute to Julia, there's also a bunch of other non-technical, I say non-technical, but it's still kind of technical, ways in which you can contribute to the Julia community, or perhaps more generally any open source community. So whether it's, you know, creating content on YouTube and sharing that with the world, whether it's hosting an event like the one that you're all at right now and giving a talk about Julia, I think again is a great way. You know, I enjoy it because I enjoy sort of spreading the good news about Julia, but also it's an opportunity for me to refine my own thinking and my own sort of understanding of what the different opportunities are for people using Julia. So it's a great learning opportunity, but also a great way to share things with folks. And again, there's some other really, you know, less traditional opportunities to make contributions to an ecosystem. Like, you know, you could help run the social media for some specific open source project. You could help facilitate teaching materials. We have this platform called Julia Academy. And again, these are sort of all just, if you sort of go through like a normal lens and you look at the open source community, you might not see these opportunities to help and give back to the community, but they're there. You just sort of need to dig around and talk to people and sort of find these less traditional ways of engaging with the community. So I'm going to pause for just 1 sec, and then we'll talk about technical contribution pathways. Any questions that have popped up in the last minute?
So yeah, there are a few questions. So one question was, again, I guess that has been answered, that what makes Julia unique. So we can move on that. So there's a question by Ayush, that how long will it take Julia to get vast library support like Python?
To get fast libraries?
To get, as like Python has a lot of libraries as of now. So how much time will it take Julia to get some to that stage?
Yeah, that's a great question. It's a big network effects, compound growth problem. I think Python had a 20-year head start, or Python was created in like the 1990s, I'm pretty sure, or something like that. So it's been along for a long time. I would say that there's a lot of sort of energy and thought being put into Julia. My guess is, if Julia ever did catch up to Python, as far as the number of packages, it probably won't be for a while. But the nice part is that you sort of don't need, again, we don't need to have the same number of packages as the Python community. One of the really cool things that I didn't touch on yet, but the interpretability in Julia is first class. And what I mean by interpretability is the ability to embed other programming languages in your Julia code. So there's a functionality to embed R code. There's a functionality to embed Python code. So you can actually have a Julia file which calls Python functions and uses Python libraries all inside of your Julia code. So if you have some, if there's some area where Julia is really lacking compared to Python, you can use that Python code in your Julia file, and then still take advantage of some of the performance improvements of Julia, which is really cool. So I would suggest checking that out if there's areas where Julia hasn't built a package yet.
That sounds really fascinating. So another question was, that is debugging in Julia as easy as it is in Python? Like, how is like debugging in Julia basically?
Yeah, this is another, people are, perhaps these are all loaded questions because folks know the answers, and I'm getting set up. But the debugging situation in Julia is interesting. So there's obviously the sort of very traditional sort of way that you would do this, and you just throw a bunch of print statements in wherever you want. But there is also a debugger in Julia. The problem is debuggers with JIT compiled programming languages tend not to mix really well. And it's one of the areas where, the debugger works and it exists, but if you have a really computationally intensive problem, it takes a while because of the way that I don't have a really deep understanding of JIT compilation nor the way that debuggers work. But my understanding is that it can't do the normal JIT compilation process when you run your code through a debugger, because it has to like step through it in a different way. So it ends up just being really slow if you want to try to debug whatever is some like really computationally intensive problem. That's the only time I've ever used the debugger, is when I was the team that I was working on at NASA, and there was some like really deep computational problem, and I wanted to try to use the debugger. It didn't work very well. But I think for sort of general use cases, the debugger is built into VS Code. You can sort of put breakpoints, check the status of variables, all that good stuff, and it should work like a charm.
So yeah, that was interesting. So there's another question, that how do you like work for, if you wish to like contribute for GSoC in Julia?
This is a great question. I had some slides in here originally that I moved around just because technically the GSoC deadline has passed. I think this year, just generally speaking, GSoC is such a great opportunity, specifically with the Julia language, just because of the sort of breadth of the packages and the different stuff that you can work on. There's so much different stuff that you could do, and I would suggest folks take a look at the Julia languages website under the GSoC tab up in the right hand corner. But again, there's a bunch of really good opportunities to, if you want to build something impactful in the Julia community, and perhaps you want to get paid to do that. I think that there's a bunch of really good opportunities, whether it be GSoC, whether it be we're always participants in Google Season of Docs, which is the technical writing version of Google Summer of Code. We have a bunch of grant initiatives, whether it's money provided by Julia or whether it's money provided by this organization called NumFocus, which is our financial steward. So there's lots of opportunities. If you build something that's really impactful for the community, there's a good chance that you could get funding to do that and to work on it on a more full-time basis.
So I guess that would have been really helpful. So yeah, these were the questions till now. I guess we can now continue forward.
Cool. So one of the ways that, again, we sort of haven't talked about technical contributions yet, technical and like that you're actually like committing code into a repository. But again, the sort of two easy, more traditional ways of finding perhaps just a starting point, and this might not actually lead you to exactly what you're looking for, but again, it could be a good starting point. On the Julia Languages website, the bottom right-hand corner has all of the Julia help wanted issues across the entire ecosystem and all of the Julia good first issues across the entire ecosystem. So if you're sort of, perhaps a little bit of Julia syntax, just enough to be dangerous, and you want to go and find, some good places to at least start your thinking about, now that I have this background in the Julia syntax, how can I go and apply what I've learned and make some technical contributions? The bottom right corner, again, of the website has these links, and you can go sort of start to look at some of these issues and see what they might be. And again, perhaps it's just worth looking really quickly at some of these different issues. And I think my screen should still be visible. But if we go down, we can take a look at some, let's look at good first issues. And hopefully I'm still signed into GitHub. I am. Awesome. You can sort of really quickly just start to see the breadth of what's possible here. You have Julia Music as an example. You have a Microsoft package called Optical Sim. You have this package called Pluto.jl, which is similar to Jupyter Notebooks. It's like a different version of Jupyter Notebook. So all these completely different areas where folks are looking for help. And again, these might not end up being, I think one of the challenges that I see with GitHub and with open sources, people put the tag good first issue on their issues, and it's really not a good first issue. They're just saying that it is. So I would, again, perhaps use this as a starting point, but it might not really be, some of these issues might not really be good first issues, but just dig through this and see if there's things that perhaps look interesting. And again, you can sort of just see how many different, these are all completely different areas where you can contribute to the language. So I'm reading this and I'm getting excited. I'm like, ooh, I could go knock out some issues after this and help make some contributions. So I would definitely check this out. And again, it's if you go on the Julia Languages website and you just scroll all the way to the bottom, there's the link to good first issues and the link to help wanted issues. And I just had a screenshot of what this looked like. The other interesting way, so perhaps you sort of, again, know a little bit of Julia syntax, or you're learning a little bit of Julia syntax, but you don't necessarily perhaps there's like a specific domain that you're interested in. There's this website called Julia Hub, and Julia Hub basically allows you to explore and look through and search a bunch of different, basically all of the registered packages in the Julia ecosystem. You can see in the bottom right-hand corner some like popular tags for the languages and popular packages, et cetera, et cetera. But this could be a great tool if perhaps you know some specific thing, like you want to contribute to, you know, biology packages in Julia, because biology is really what gets you jazzed. You can use this Julia Hub tool to sort of look through all the different packages and find things that would be relevant to you. So I would suggest, again, if that's of interest to you and you know some specific domain perhaps where you want to look, I would check this out and see if there's packages in the specific area that you're interested in. And if there's not packages, again, just another really good opportunity for you to sort of be the leader in this area in the Julia community and make a real impact. So that's another really exciting opportunity. So I answered this question a little while ago, but the Julia language does participate in Google Summer of Code. I know this presentation is like 1 or 2 days after the Google Summer of Code deadline. But if you end up being eligible again next year, I would keep it in mind if there's some stuff that you want to get involved with and do some projects. My disclaimer is the same as always for Google Summer of Code. I think the people who get chosen for Google Summer of Code are usually the people who have sort of been around the community and the language for more than like 2 weeks. So if you're like, you know, again, if this is intriguing and Google Summer of Code is something that you're interested in doing, get started contributing to whatever the domain is. Even if you apply for a project that's not specifically what you spent your time working on over the course of the year, I still think, you know, you're in a really good position. If mentors see Julia open source contributions, you've contributed to a bunch of different stuff, they'll be very excited to see your proposal and to see your application. So I would definitely give it a shot for the future and keep your eyes out for other Julia related opportunities to get funding to do your code development. So one of the other pieces about why learning Julia for students is such an impactful thing that we have yet to talk about is this notion of sort of the impact on your professional career. So I think sort of, you know, at a high level, you know, obviously doing programming in your free time or for school is going to be helpful when you go to get a job, because, you know, they're going to want you to know how to program if you're going to be a software engineer or developer. But one of the other really interesting things that I think people sort of forget until you get to your first job is that sort of the reason companies hire graduates from university is that they're interested in a fresh perspective. You know, if a company wanted to hire the best developer, for the most part, they wouldn't be hiring people who are straight out of school. They would be hiring people who have a bunch of experience. But again, the challenge with people who have a bunch of experience is they have very particular ways about how they want to do things. They know a particular set of tools, et cetera, et cetera. But people who are coming straight out of university have all these cutting edge things that they've done. They've used cutting edge tools. They know new skills that perhaps people who are in the workforce have yet to learn. So this, again, I think Julia is one of these things that you can go into an interview, and I sort of experienced this firsthand when I was interviewing for jobs. I sort of went in and I, you know, had this different perspective. I can remember I was interviewing at Shopify, and I didn't end up getting the job, but I was interviewing there, and they, you know, it was one of those very traditional interviews where they were sort of, they had me share some code that I had written, and we sort of talked through it, and they asked me how I would solve this problem using some language. And I was sort of showing them a Julia project, and they sort of, the people who were interviewing me had never heard of Julia. They had never seen Julia code before. And it was a fun experience for me just outside of the interview process, but it was exciting to be able to share this new thing with these people. And I think, again, maybe this isn't true because I didn't get the job, but perhaps I can assume that they sort of saw this, and they were able to see that I was sort of passionate about this thing, and I was really interested in it, and I was engaged in this language and doing development in it. So I think, again, this is such a unique opportunity for students to learn something new that's different. This learning Julia makes you different than all your peers who just know Python and Java, and then you can leverage that to actually go into an interview and show folks that you have some new skill that would be valuable to them, and whatever the company is. So it's definitely something that can be overlooked, and something that I always want to point out to folks as an interesting thing. The other piece, and this was something we were talking about before this call, is that the Julia community is such an awesome place. And I think it's one of the reasons that I stick around, is that there's just so many folks who are really kind and willing to spend their time to help people and things like that. It's awesome. And I can't say enough good things about the people who are in the Julia community. And I would, it's a ton of fun. I would suggest getting involved if you haven't. But yeah, that's sort of all that I have. I can hop into a really quick code demo if folks want to just see some syntax. But I know I've been talking for a long time, so I'm also happy to not do so as well. Whatever is of interest to people. I can make it a quick code demo.
That sounds wonderful.
Let me see if I can switch my screen. Wonderful. So we should be able to see my terminal. And we've got Julia open right now. You would, if you open up your terminal and you install Julia, you would open it the same way that you would with Python, and that you type Python and it opens up. So I have Julia open. We can sort of just look through some of the really high level syntax. If you were to do something like, we'll stay on brand with introduction materials, and we'll say hello world. We'll print that out. We'll see the result of that. Nothing fancy or sort of convoluted happening there. If we look at some of the syntax, if I define a list and I'll just incorrectly name it A, and I say it's a bunch of different numbers, and then I say for item in A, and then I print item. One of the interesting pieces about Julia is if you see this code block here that I just wrote, I wrote the word end at the end of the code block. So again, one of the syntactical differences between Python and Julia is that Python uses the colon at the beginning of a code block, whether it's a function, if statement, a loop. In Julia, they don't use the colon, but they do use the end keyword to denote the beginning and end of a specific code block. So if I run this loop, you see that happen. The only other thing, and I won't bore you with all the basic Julia syntax, the really cool thing that I do want to show is the Julia package manager. And perhaps, for me still, I've been programming in Python for like 6 years now, and the package manager to me still confuses me. Like I really don't have a good understanding of how to use pip or any of the dependency management stuff in Python. I think in my opinion, it could be better. It could be well designed. to be more clear. But in Julia, the way that there's a package manager actually built in. So if you have the Julia REPL open, the read, evaluate, print loop, if you have it open and you type a left-facing square bracket, like I have shown here, except without quotes, if you type that, it takes you into the package manager. And then from here, I can do something like status, and this will tell me what packages I have installed. So right now I only have one package installed, and here's it's showing me the path to the environment file. So already this is, a huge improvement over something like the Python package manager. And then I can add things. I can add Flux, which might take a little bit of time, but Flux is the de facto machine learning library in Julia. And now it's going in to the registry, finding the package, doing all the installation stuff. But this is super important because using the Julia package manager, you can make your code reproducible and you can share your environment with folks. And this again sort of solves a lot of the problems that Python has in your ability to share code and make it reproducible. So this progress bar down here that you're seeing is actually really cool. So with Julia 1. So it just again speeds up the entire process for people who are downloading packages and all that good stuff. But we'll wait for this to finish, and then I'll show one more thing about the package manager, and then we can take some final questions and wrap up. Come on, CUDA, you can do it. If anyone's not familiar with the CUDA package, CUDA is how you do GPU computing, not just in Julia, but just generally CUDA is the name of the GPU computing package. So there's native GPU computing support in Julia as well, which is interesting if you're trying to do some like really computationally intensive stuff. It's nice to be able to do those operations on the GPU. So we just installed another package. If we again type the status command, now we can see that the environment's been updated, and we now have Flux as well as Franklin installed. I could do type the word help. This will give me all of the different commands that are accessible. There's a bunch of stuff built in that makes it easy to manage packages that you're actually developing, which again is something that I'm not familiar with in the context of Python. I don't even know how you would do that, but if you're developing a package in Julia, it's really easy to specify that package. There's ways that you can add other registries, which are just basically services that provide packages. So there's like specific universities in the world, like Stanford has a few labs that actually maintain their own registries, which again is just like its own repository of packages that folks can hook into and then get access to. So a bunch of really powerful stuff that can be done with the Julia package manager. And it's worth taking a look at this if you're sort of like me, frustrated with the way that the Python package manager works. But I'm going to unshare and pause to see if there's other questions. Hopefully folks are intrigued by Julia. And I think at a high level, I'm available to answer questions if you sort of start learning the language and you want to get started and sort of aren't really sure what to do. Just shoot me a DM on Twitter or something like that, and I'll do my best to help get you pointed in the right direction.
So what are the challenges that Julia is like? What are the challenges that Julia is right now focused on tackling?
You mean like for the language, like the way it's being used itself?
Yeah, like basically how the community is working. Some like maybe they are trying to tackle a very specific problem related to just one of the field, like maybe computational mathematics or something.
Yeah, that's an interesting question. I think something that just popped into my mind that hasn't, I don't know a lot about this, but this new package that just recently came out is called Symbolics .jl. And again, I don't have a good understanding. I think they're building like a, I'd have to go look up exactly what they're doing, but I just know that they're that's something that if you're looking for sort of the cutting edge stuff that's happening in Julia and new problems that are being tackled, symbolics.jl is a good place to look if you Google that. I need to go read more about it and make sure that I don't make claims that aren't true. But I do know there's a lot of attention and interest in this new package that's being developed.
So there's a question that if you can suggest some projects like which people can get engaged in, or like there are some projects which you think that people should get engaged in.
This is another great question. This is actually something that I was thinking about the other day, that we should do a good job of sort of marketing and putting together a list of packages and ecosystems within the Julia community that are sort of really welcoming to new contributors. I would say in general, it really depends what your interests are. Like, I think for me, if I'm doing Julia stuff in my free time, I'm either contributing to documentation stuff. I'm finding, there's a lot of scientific stuff happening in the Julia community. I think for me, one of the challenges with that is that, I don't have a background in some specific scientific domain. I studied computer science in school, so I just know how to program, and that's pretty much all. So if you have a specific scientific domain that interests you, Julia is such a great place to be. But I think, again, the other opportunity and the reality is that there's so many folks who have a really great scientific background, that there's also these gaps where, there's these pure software engineering problems that don't require any scientific background. And those problems don't often get as much attention as the scientific stuff, just because folks are more interested in doing the science stuff, that you could really come in with just a background in pure computer science and go and have an impact, whether it's, helping improve the tools that we use to generate documentation, which, might not sound like the sexiest thing, but if you think about it, there's one package called documenter.jl. And this documenter.jl package powers the documentation for all of the packages in the entire Julia ecosystem. So you could go in, and again, there's no scientific piece of that. It's very much a pure computer science software engineering project. And you could go into that and contribute stuff, and it should be relatively straightforward. So I think that's one of the really cool projects where you could go and make contributions.
So last question, which is again, from the startup pack that everyone keeps asking, how do I get started with Julia? And I guess if you can end that with some closing remarks, that would be great.
Yeah. So the best way to get started, and again, it really varies how you think that you as an individual learn. So I think if you haven't thought about what the best learning path is for you as a person, I think take a few minutes before you try to learn Julia, think about, what is the best way for me to learn? I think when I think about this for myself, I really enjoy the sort of classroom experience and having a lecture, and I can see examples and take notes and things like that. So I gravitate more towards these like online classes that are around Julia, but there's a bunch of different ways that you can have this happen. I would go to the Julia language website, go to the learning tab up at the top. And there's, we have a ton of completely different avenues that you can go and learn Julia. So I would send folks there, take a look at the resources, see what works best for you. And again, if there's questions, feel free to shoot me a note, and I'm happy to answer more specifically.
So thank you, Logan, for this beautiful session that we had. I guess that will have motivated more people to explore about Julia at least. And I guess a lot of people will now try to hop onto the boat. So thank you everyone for joining in. You can always shoot him with questions on his Twitter handle. And you can find the link to the MIT OCW course in the chat. So thank you everyone for coming in. Hoping to see you in the fest. Goodbye.
Yep, this was awesome. Take care, everyone, and good luck hacking, and hopefully you can build something awesome.